Okay. Can you hear me now?
Yes, sir.
Okay. So I'm just sharing. Just hold on. Is my presentation visible?
Yes, it is.
Okay. So first of all, thank you very much for inviting me to deliver the talk. So today, the topic which I'm going to present here is a new for me also. I never give this talk anywhere. So I prepared this talk for this FDP program because this is important for anyone who is in the field not to repeat the same thing. Because if you do the same thing repeatedly, then you will be bored. So today I will try to cover the topic which is explainable machine learning techniques. Though our group is working from last number of years in the field of machine learning techniques. Because over the years it has been realized that machine learning techniques become the black box. It's difficult to interpret their outcome or result. So, if you are interested in my services or in my group, then this is the website. You can note down, as well as organizers may share my slides with the participant. I will send the slides also. Because the whole idea is that no reinvent of the wheel. Means, let's say if I work hard to prepare these slides, why you should do the same thing? So you can think about the much more advanced thing rather than doing the same thing. Okay. So this is the my site from where you can get our web services. Now, we have to understand some facts because there is a lot of confusion sometimes between the AI, machine learning, deep learning. So there is a lot of confusion. So I will say AI is a big umbrella. Artificial intelligence includes many things. Machine learning is a subset of artificial intelligence. It is a subset of AI techniques. Because machine learnings are mainly used for classification or regression or prediction. Okay. Within the machine learning technique, we are going in the more depth, and that is called deep learning. So, in brief, deep learning is a subset of machine learning. So today, I will focus on the machine learning and particularly how to understand the outcome of machine learning techniques. So before I go further, we have to understand where we need to use the machine learning technique. First application is in the regression type of models. Let's say these are the input variables, independent variable, x1, x2, and this is the outcome. And here, the outcome is a continuous value. So now, up to this point, we have the questions, means input variables, as well as the outcome. Now, from here, you have the input variables, but you don't know the outcome. So, in case of machine learning, we will learn from this data, which is called the training data set. We will learn from it, we will train our models, and we will predict these queries. This is called test data set. Okay. So first we have to understand what is a model. So model is nothing. Model is a set of rules. Set of rules we learn, we deduce these rules from the training data set. So here, using the machine learning, we will train our models from this data, where we know the input variables as well as the corresponding outcome or labels. Okay. And based on this model, we will predict the remaining sets, where input variables are there, but we don't know the outcome. So that's the idea. This is the one type of problem machine learnings are used, and this type of models are called regression models, or we also call the prediction models. These models predict the real value of the your instance or your query. So here you will get some value, something like 1.5 or whatever outcome is there, you have to predict it. So this is a real value. So we call the regression value or prediction. There is another type of predictions which is called classification. So this is the example. Here, this part is same. Okay, but outcome or output is now in the categorical form. It's only two colors here, black and white. So these are the two classes. So we have to predict for our query either black or white. This type of classification is called binary classification, where we are predicting only two classes. It is possible that we predict the multiple classes. So this type of models are called classification models. These are called classification models. Same way, we have to train our machine learning technique on this trained data set, where we learn our models, and then we have to apply the same model here, where the input variables are given, but we have to predict the outcome variable. This outcome variable here will be two classes only, either black or white. So this type of models are called classification models. So machine learning technique is used mainly for two purposes, either for classification or for regression. Because it is important for you when you are working on any topic or you want to learn any topic to understand its application. So these are the two major applications of machine learning. Okay. And models are nothing, it's a set of rules we derive from the training data set. And this set of rules is applied to predict the unknown data, where outcome is not known. Right? Now, before I go further in the explaining the machine learning, we have to understand the type of machine learning techniques. Type of machine learning technique. Broadly, it can be divided into categories: supervised, unsupervised, reinforcement learning. Please try to understand one thing. That field is changing very fast. Even I am in this field from last number of years. I always feel I am always behind. I am not able to cope with the change in the field. Earlier, in our time, there was no such type of technique called reinforcement learning. We know only two techniques. If you go to the standard books, any standard book, they will teach you two types of machine learning techniques, supervised and unsupervised. Nobody talk about the reinforcement learning. But nowadays, this is a new field. It's called reinforcement learning. So first, come to the supervised learning. So I have already given you the example of supervised learning in last two slides, where I have given you the example of classification as well as regression. So the last two slides shows the classification and regression. They are both under the supervised learning. Why we call the supervised learning? Because we know the input variable as well as we know the outcome. So that is called supervised. Here, we are training our data set and we are checking our model whether the model is right or wrong. That's why it is called supervised learning. Okay. And if you go to the classification, there are a number of models, machine learning techniques are there: naive-Bayes, decision tree, support vector machine, random forest. I'm not going all. This is just few examples. If you go to the regression, then popular ones are linear regression, neural network regression, support vector regression, decision. These are some of the names of regression. Unsupervised learning, we know the input variables, we know the feature of the instances, but we don't know what is the outcome because there is no label is known. Then we do the clustering. We group the data based on the input variables. So these techniques are called clustering techniques. Popular ones are k-mean clustering, mean shift clustering, DBSCAN clustering. So these are the few names. Now third one is popular from last 10-15 years. That is called reinforcement learning. Most of the big platforms are based on the reinforcement learning. For example, when you are doing the Google search, so that is not based on the supervised learning. It uses the reinforcement learning. Have you observed that when you do the search on the Google, then so next time when you do the search on the same keyword, you will get the hits which are more relevant hits with the time. How it detects that what is relevant to you? Because when you click in a search, it note down that for you, you like these hits against this keyword search. So this is called feedback learning. Means they get the feedback, Google search get the feedback that the user for the given keyword they prefer websites. So these websites get the more weightage. So next time the chances is there that in your keyword search these will be on the top. So that's called feedback learning, or we call reinforcement learning. Same is true with the Amazon or any platform where user gives the feedback. Based on the feedback, they suggest you which item will be more suitable to you. Okay. So reinforcement learning is becoming very popular nowadays. So these are called decision making techniques. And popular names are Q learning, R learning, TD learning. Okay. Though today I am not going to talk about the unsupervised learning or reinforcement learning. I am going to talk only supervised learning and their explanation. Okay. Now, just try to understand the concept. Because I know it, within the 1 hour of my class or this lecture, it is not practically possible for you to learn all these things. But even if you remember 10%, and if you remember the concept, that is more than enough. Because you will only learn when you need it and when you will apply in real life. That is fine. But most important part is you have to understand the concept. So this is a typical concept of supervised machine learning. That is a concept of supervised machine learning, where you have the training data set with their labels, means with their outcomes. Then you apply some machine learning algorithms. Like neural network, support vector machine, KBS neighbor, decision tree, random forest, and they will drive the rules. That is called models. They drive the rules, and these rules are called the models. For example, in case of the neural net, what you will learn? You will learn the weights. Weights. Okay. So once you know the weights, then applying neural network is easy. Then challenge is new data. New data means where input variables are given, but outcome is not given. Then you will apply the predictive model, set of the rules, and then you will do the prediction. So here, in this example, right side, this part, this is called training data. So your model will take this data. Here you can see these are called the labels, and these are called the input variables. Okay. So here labels are given. So applying the machine learning technique, and you develop a model. Then new data. New data means you only know their input variables, but you don't know the outcome. You don't know the outcome. Then with the help of this predictive model, you will do the prediction. You will get maybe somewhere here, let's say black, white, anything. I am just putting like that. So you will do this type of prediction. So this is called prediction. This is called prediction, right? So this is the concept of any supervised machine learning technique. This is another example. Here, you can see in the data set, there is no outcome variable. There is no output. Okay. And that is called simply unsupervised learning, because we have nothing to check whether my classification or my grouping is right or wrong. I cannot check it. In previous example, I know the label, so I can check it whether it is right or wrong. So here I don't know. So I have to do the grouping. Let's say just think about it. Number of participants are there in this conference or workshop. Now, I can group you based on the different quality predictions. Let's say I can group all the faculties in one group, all students in another group, all staff in another group. So I can group them actually based on their properties, based on their characteristics. That is called clustering. Clustering, or in simple word called grouping. So we are grouping. So here, one type of examples or instances will be in the one group, another, this is another group. So each group have the one type of objects, one type of candidates, whatever you call it. Now question is basically what is a reinforcement learning? So here is some environment. Your agent takes some action, and this action is in the favor, then it will give some reward. And we say that action is right, in future this action can be repeated. If action is wrong, then it will do the punishment. So your models will be trained based on the feedback. Let's say some user buys some equipment from the Amazon, and they say that high rate, they like it. They say this is an excellent product. So that you will suggest the same product, Amazon will suggest the same product to the other users. Maybe later on, more and more users say this is a useless product. Then Amazon will not display this product because the product is not good. So it's a real-time learning. Rather, in case of the supervised learning, what we are doing, we are taking whole data at a time and then we are doing training. And here, what we are doing into the based on the feedbacks. So this is the environment. And nowadays, reinforcement learning is very popular. So when we talk about the problem of regression and classification, we have to understand certain things, what type of techniques are already available in the market. If you talk about the statistical technique, for linear regression, you can use the regression, multiple linear regression. If you are doing the classification, then there is a different type of classification: logistic regression, region regression, lasso regression, elastic net. If you want to apply the machine learning techniques, you can apply ANN, support vector machine, random forest, hidden markup. So I told you in previous slides also, machine learning we are using mainly for regression problem or classification. Classification may be just hold on. Okay. So classification may be binary classification or multiple class classification. Okay.
ये इंडिया का ट्रेन हम लोग को बंद करना चाहिए सब में वो करता है ना
so this may be any classification. Now why we need it, that's the question is basically why we need explainable machine learning techniques. Because machine learning techniques fine, no problem, why we need the explainable machine learning technique. You see the example, whether it's basically simple neural network, non-deep neural network, or deep neural network. There are too many hidden layers are there, too many hidden units are there, and then output layer is there. Though you will get the output, but you don't know why you get that particular output, right? It is really difficult to interpret the results of machine learning techniques. So nowadays, researchers have realized that we need the machine learning or AI techniques which is more convincing to the human being actually. Because at the end of the day, human being has to use all these techniques. If human being is not convinced, they will not use these machine learning techniques in real life. It will be only in the research only. Nobody will bother it. So in order to bring the machine learning technique or AI technique in real life, we have to do some explanation. Why it is happening, why this particular result is there, why it is not there actually, what will happen if I change a little bit in the character of the object. Okay. So we need the explainable AI. So this is basically just example I have tried. Just hold on. So now we have to understand what are the different ways to explain the outcome of machine learning technique. There are two processes. One is intrinsic or interpretable machine learning types. There are a number of machine learning techniques which have built-in capability, internal capability, that you can easily understand the result. That's one way. Okay. So that is called the intrinsic technique, where the machine learning technique itself have the provision to explain the outcome or interpret the outcome of the machine learning technique. This is the one category. I will tell you what are the different type of techniques which are self-explanatory. Another technique is post hoc.
That's
It's
why I
not
said
post-doc,
before,
it's post-hoc.
So
After
bukan
training
bisna
means
time nanti gua pura
you
kita
use any machine learning technique, it does not matter. But these techniques will
social life lagi umum nasi
analyze the individual predictions or entire model
social life
to understand what is the why the particular outcome is there, what is the probability that this prediction is right or wrong. So again in the local, you have the model specific, okay, model specific or model agnostic. Model specific means only work for a specific model due to definition, and model agnostic means there are number of Python libraries there which are model independent. You predict from any machine learning technique, and these libraries like Shapley values, line, contrafactual values, they will explain the outcome and they will tell you why the particular result has come. So that is called model agnostic in case of the local. In case of the global, we have to do the combination of the two, where we are trying to understand the individual predictions, and here in the case of the global, we do the prediction of the whole data set, and then we are trying to understand the meaning. Okay. Now, I will go systematically. So systematically I will go. We have to understand one problem actually. Sometimes when we make it more explainable, accuracy decreases. So we have to make sure that we maintain the both accuracy as well as interpretability or explainability. Okay. These are the examples. You can see decision tree is the one of the best techniques for explainability. Anybody can understand decision tree. I will just cover later on. Okay. You see, explainability is very high actually. But if you see the learning performance or accuracy, then this is a low end. Okay. This is low. In contrast, deep learning technique, accuracy is very high, learning is very high, but explainability is low. Random forest is in between. So we have to see in which situation, which technique I have to apply based on my requirement. If I need the more explanatory, then I will go for decision tree. If I need more performance without the explanatory, I will go to the deep learning. So we have to understand this part. We have to see whether we are compromising with the interpretability and accuracy. So here is another example of accuracy and interpretability.
Excuse me, sir.
Yes.
Sir, can you raise your voice a little bit more?
You want more explanation of this one?
No, sir. Your voice is not audible.
Oh, now it is audible? No.
Yes, sir. Yes.
Okay. So I will be a little bit near to this.
Yes, sir. Yeah. Thank you.
All right. So we have to make the balance. So here again the example, linear regression, decision tree, they are more interpretable, but same time their accuracy is poor. Where the neural network and other techniques, the accuracy is high, but interpretability is less. So we have to balance between these two.
ऑफलाइन तो वैसे ही चलता है कैसे मतलब एक टोकन होता है नहीं दूसरा कंप्यूटर
Okay. Now,
कंट्री में ब्लैक मनी
these are the some examples where the models itself have the provision of interpretability.
ऑनलाइन में ऐसा है
Like for example, linear regression model. They are very easy to understand. Logistic regression, decision tree, naive Bayes. These are the some examples. I will go So, in order to understand, I have divided these models, which itself have the provision to be explainable, okay, which are designed in such a way that you can understand why you are getting the particular result. So here, one is prototype-based models. Prototype-based models means you are doing the prediction based on certain instances, certain examples. I will come later on. Second is rule-based models, where you design if today it's a rain, heavy rain, then I will not go for the outside because rain is there, so I will not go for play. If it's a sunny day, it's not humid, I will go to play because that will be suitable. So these are called rule-based actually. So that is a examples of decision tree, Bayesian classification, random forest, are the fake examples. Then there is a risky score. You predict whether it's risky or not risky. Okay. So best models are logistic regression coefficient, risk assessment models. Then there is another class, journal additive models. Because the problem with the logistic regression or linear regression is that they believe that there is a linear relationship between your characters and your outcome, between your features and outcome, between your attributes and outcome. So, in additive models, they handle non-linear models. I'm talking about the models which can be easily interpreted. So now I will talk first about the prototype-based models. So one of them, which is commonly used model, is basically K. That is called K nearest neighbor. Is one of the prototype of models. These prototype of models where you are doing similarity search. For example, if you are a biologist, you are heavily using the blast search. In blast search, we take a query, do the similarity search with all the known sequences. If my query have the high similarity with one of the known sequence, then I will assign the same function. And that is same way is the KNN, K nearest neighbor method. Okay. One message I want to give here to the participants. Instead of learning, instead of reading the books, instead of listening to the lectures of the expert, just think yourself how you learn. Because all these machine learning techniques is based on the human's tendency of learning. So they are not new. They have program, they develop the program so that machine means computer can think like you. So you are the best learner actually. So you have to understand how you think yourself. So one of the techniques I believe work like we work. That is called K nearest neighbor. So how we learn in our life. That's a thing from your childhood. How you learn. You do something, then your parents say, no, this is wrong. You are doing some other activities, then your parents say, yes, this is right. So, every time when you do the activity, somebody tell you in the beginning that this is right, wrong, or what is your name, or so. So when you get the new question, new thing actually, which you have not seen earlier, what you will do? You will try to compare that object with the already known object in your memory, where you know the answer. You have seen the car, you have seen the, let's say, buses, but you have never seen the truck. Then all of a sudden one day you get the truck. Then you say, oh, look like more like bus actually. Then you say to your father that this is a bus. Then they will say, no, this is not bus, this is a truck. So you will remember it. When next time you will have the truck, then you will go search in your mind that this size I have, this type of object I have already seen in my life. That was a truck. So you will assign it truck, right? So we all learn from our childhood from based on our memory. So how you recognize your friends and other things? Because you know their size, shape, and everything in your mind actually. So your memory is there. When you get somebody from the long distance, you look the size, shape, and everything, and then you guess it. Oh, I have seen. He's my friend XYZ. So that's called KDS. One of the problem I have seen in most of these students and candidates, they read the books, complex books, but they are not trying to understand how we think ourselves. So one of the easiest techniques which is commonly used by most of the human beings for learning from childhood is KDS. I will talk in more scientific way now. So let's say this is a training data set. This is the example of training data set where you know the label and the colors. Now you have the new example. So what you will do? You will find out the similarity with already known examples training. And if you find this query is more close to these objects. Now it's too many objects. One way is to find out, because it is closest to this one, you can assign this one. But that will be based on the one example. But here is the many examples are there which are quite close. You can see what are the different colors. So here this color is more, you can assign this value. So that is called K nearest neighbor. Here I am giving the examples. If you say K equal, these are the classes. These are the classes: star, triangle. Okay. These are the class A and class B. You have the new object. You don't know which one is the nearest, and you found that if you take K equal to 3, with 3 nearest object to this, then there is a 1 star and 2 triangles are there. So based on this K equal to 3, you will assign this as a triangle, because you have the 2 triangles, so you assign it triangle. If you go for the K equal to 7, then there will be 3 star and 4 star and 3 triangles. You will assign it as a star. So it depends on the how many nearest neighbor you are using to take the decision. So that's important. Decision has to change depending on the how many nearest neighbor, how many similar objects you are taking for taking the decision. Okay. That's another example. Here, if I am taking K equal to 1, then it is assigning class 1. Okay. If I take K equal to 3, then I am assigning class 2. So it is important for you to understand the decision also depends how many neighbors I am using for assigning the label. This is another example. I am just jumping in. So what we should to do in the KNN? So step 1, we have to do the initialization, means where is our given point, and compute its distance with all the points. Compute the distance of my points with all the points D1, D2, D3, D4, blah, 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 blah. The distance can be calculated by Euclidean distance, Manhattan distance, or it may be similarity, because distance is a opposite to similarity. Okay. So you can calculate all these distances. Third, you have to find out,
lucky for you though,
or you have to sort out the objects based on the distance. Let's say I am taking k equal to 7 here. So this is the most closest. Next, 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 next. So now I can see this color is 3. This color is 4. And this color is 0. So in classification, I will assign this color to my query object, my given point, because more and more points are close to this particular color. But if I take the k equal to 5, then situation will change. Here it's 3, it's 2, it's 0. So I will assign this one. So it depends what value of k you want to take. So then you will ask me the question, what should be the right value? It depends on what type of prediction you are looking for. If you are taking a small value of k, your performance will be low biased, will be same type of thing, but high variance will be there. Overfitting chances is very high if you are taking the small k. If you are taking the large k, like k is equal to 7 or k equal to 15 or whatever big number, then it will have the high bias, low variance, and underfitting. So, what should be the best value of k? Which balance between underfitting? That's a challenge. Now, why this k-reasonable is preferred in this business of learning? Because here it is known to you that this is your query and how many are examples are close to your query and what is their different labels. So you understand what is going on. So everything is transparent, visible. That's why it is called explainable or interpretable. Okay. So similarly, if you want to apply the KNN for regression, in that case, you have to add the real value of yes. All right. So you can add them.
Sir, sometimes your voice is dropping.
I don't know how to handle the voice.
No, sir, it's perfectly audible.
Okay.
Yes, sir. It's audible.
Okay. So here you can take the average. Let's say this is a real value. Maybe let's say this is value 5, this is 10, this is 7, whatever. This is 8, this is 9, some values are there. Then we can take the mean of it and this will be the outcome of your value. So KNN cannot be used, is not only used for classification, but it can also be used for the regression problems. Okay. Now, when you are doing for classification, this is the formula because sometimes you want more mathematical actually. So we have to take the k equal to 1 and we have to k maybe 5, 7, whatever the number you want to take it, and then we have to count the maximum number. Okay. So if it is maximum number, then we count that what is a function. In case of regression, we simply take the mean of it. We have to understand one part. In KNN, why I am talking about too much about KNN? KNN is mostly based on the facts actually, that if distance between your query and your target is less, let's say identical, then chance that it will have the same outcome is very, very high. If distance is high actually, between your query and target, then its performance will be poor. So the weight of prediction depend on the distance between your target and your query example. That's why KNN is completely explainable. You understand that how much distance you have get it. Let's say you get the zero distance and you are doing the prediction. You can be sure, 100% sure that your prediction will be right. That's why the KNN provide you not only the prediction, it also provide how similar or how much distance is there, because distance is inverse proportional to the similarity. Means if distance is zero, it means 100% identical, they are the same thing. So weight is an important part. Another is feature, because all features, all input independent variables, all input variables are not equally important. Some variables are important, some variables are not important. Then you can assign the weight, and you know in advance that these are the reliables and these are not reliable. So feature weighting is also possible in the KNN. Instance weighting, that's very interesting part. Because let's say, just think about it. You have too many friends, okay, and you take the decisions based on their outputs or based on their advice. But all of your friends is not equally reliable. Some of your friend is there which always tell truth, but some of your friends are there which also give the loose remarks. So during your making your decision for anything, you will rely on your friends which are most reliable. Similarly, here when we are doing the similarity search with the instances, all instances are not equally important. So we also assign the weights. So you know it, in the past, this instance or this friend give you the most reliable results. So you will believe on the most reliable person rather than believing on the other person. So here the instance weighting is also there in KNN. So that's why KNN is called intrinsically or interpretable machine learning techniques. I'm not saying this is highly accurate, but it is highly interpretable, highly explainable. Each and everything can be explained. Okay. After this is another technique called rule-based technique. Just think about it. You go to your administration. Let's say you are the employee. You go to the administration. You ask the person, what will be my total pay? Then the person will ask from you, what is your basic pay? You say, my basic pay is 1 lakh rupees. The person in admissions will say, if your basic is 1 lakh rupees, then your DA will be 40%, means 42,000. It means your pay will be 1,40,000. Then HRA will be nearly 25%. So then 25,000 you can add it actually. Okay. Then this will be something like 1,77,000. Then you get the TS, transport amount. So you will get the 2 lakh rupees. So here conditions are there. If you have the basic pay 1 lakh rupees, then 40% TA will be there. This particular TA will be there. So we know the rule regulations in the simple term. If this is outcome, else this is outcome. So these are called rule-based models, where rules are well defined actually. So when you do the prediction using rule-based models, it's very easy to understand, very easy to explain. You can easily say why you have the 2 lakh rupees income per month, because you have the basic 1,000 rupees on the basic 1,000 rupees, 20,000, this 42,000 is TA, blah blah blah. You will get. So these are called decision based. If and rules are there actually, well defined rules are there. So any human being understand and they can easily implement. Okay. So major techniques which are commonly used in this case is decision tree. Decision tree is one of the oldest technique for machine learning techniques. Okay. Then we have the Bayesian classifications. Random forest is nothing, it's a basically ensemble of trees. So here, rule-based technique, rule-based models,
yesterday तो बदले
I'm just jumping. So let's say decision tree. Let's say you see how the weather look like. If you find it's a sunny day, then you'll check whether it's a humid. You say yes, it's a humid, high humidity. Though it's sunny, but it's high humidity is there, so person will not go for playing the tennis or playing any game. But you find the humidity is normal, it's a sunny day, you can say yes, I can go for the play. Okay. So this is called decision tree, where rules are based on certain conditions. Okay. So this is the internal nodes, just for your understanding. Branch correspond and the each leaf node assign a classification. So this is another basic concept of decision tree. Let's say these are the three conditions A, B, C. Both you say here, if A is equal to G, 0, then you will check what is the B. If B is 0, then you check the C. C is also 0. C is also 0. Okay. Then you assign it M0. Okay. Similarly, let's say you don't know about this one, what is this actually, and you get this point actually. In decision tree, you will check A equal to 1. This is A equal to 1. B equal to 0, this branch, and C equal to 0. Then you can predict the M4.
Maybe. If I don't get it.
Okay, you can easily predict the M4. Alright. Similarly, you can go for the other type of predictions. So here in decision tree, it's a rule defined. If this condition true, then go this way. If next attribute, you check the next attributes. If this condition is there, go here, and then you take the final decision. So your decision will be look like that. If outlook is sunny, humidity is high, and humidity is high, then play the tennis, no. If outlook is sunny, humidity is normal, then play for tennis, yes. If outlook is overcast, then play the tennis, yes. So these are called the rules. This is rule number 1, rule number 2, rule number 3, rule number 4, rule number 5. Whenever you have to take the decision, you have to check in the rules. So this type of models or this type of prediction is very convincing or completely explainable or interpretable to any human being. Okay. That's why these are the preferred machine learning techniques for human being, where the human understand what is the meaning of it. There is another technique similar to the decision tree. Only difference between the Bayesian tree, Bayesian classification, and decision tree is that in case of the Bayesian classification, we compute the probability. Where in the case of decision tree, we simply calculate whether we'll take simply the decision, but we will not take what is the probability. So that's a difference between the two classifications. So here we calculate the conditional probabilities, because there is a two type of probability. One is simple probability. Let's say in a bag you have the green balls, red balls. Okay, then you can calculate how many red balls are there, how many green balls are there, and then divide the red ball with the total balls, and you can say this is a probability that you will get by red. But it's possible that you have the many conditions. What you will do in that case? Then we use the Bayes theorem. Actually, Bayes theorem says that if you want to predict the probability of state H in the presence of X, then this formula you have to apply. I'm not going into the detail. I will give you the example. Previous example we have seen actually in the decision tree. Now we will see the same thing into the naive scale classifiers. So here is the different conditions. Sorry. Okay. So,
No, sir. You please go ahead.
all right. So let's say in this case, these are the four conditions. Condition 1, condition 2, condition 3, condition 4. And based on these four conditions, you are taking decision whether you will go for the tennis or not. And you want to know the probability. What is probability? Okay. So if you have no conditions, you can see here total number here is total 14. 14 examples are there, and we can count 1, 2, 3, 4, 5. 5 no's are there, means no are there. So that you will not go for the play, the probability is 5 by 14. And you will go for the play and taking without any conditions. Okay. Then probability here remaining 9 divided by 14. So you will get this. Right. Now you have the conditional probability. Now you have the conditional. Let's say for example outlook. If you go for the outlook, this is the outlook here. Okay. And what is the probability outlook that you will go for the play? So here you can see here when it is sunny. This is sunny. So here in case of the sunny, you have to find out how many times yes are there. Okay. So here is the yes. Here is the yes. So in case when weather is sunny, 2 times you are going out of 9, you are going, when sunny is there, then you are going for play. Because total 9 yes are there, out of them 2 times sunny is there, when yes is there, then you say probability is 2 by 9. For no, you are counting, but total sunny is there 5. 1, 2, 3, 4, and 5. So total 5 are sunny values are there. So here we have to calculate how many times no is there. So this 3 times is no is there. But we are dividing here by 5. Here we are dividing by 9. Because total yes is 9 and total no is 5. That's why we are putting the conditional probability. So we have to understand Bayesian classification is not simple, it's a conditional probability. Based on that, we can compute it for the different case of the humidity, for windy, temperature, and then finally we can take decision that whether we will go for the play or not play in a given condition, because some, let's say you get the condition sunny, temperature is cool, humidity is there, wind is there, what is the probability that you will go for the play or not? Okay. So here, yes probability is 2.05 and no probability is 0.795. So in decision tree, we are not providing probability, but here we are providing probability. So here, you will decide whether you go or not. So this is a just rule list using the basic. Let's say if somebody has the age more than 60, then chances of stroke will be heart attack will be 58. If cardiovascular disorder, stroke risk is this one. So these are called conditions. So in Bayesian also you have the conditions basically, that what percentage, what probability will be there. Okay. So these models are clearly, easily understandable to anyone who understands the problem. That's why these are the explainable. Same we have the logistic regressions, which can also do the classification. So here, let's say we all know about this equation. This is y equal to mx plus c, and you can easily calculate these values. This is called the intercept. This is called slope. These values can be calculated by using these formulas. So, what is the advantage of the multiple linear regression? Because here we have the different coefficients, and these coefficients show the change in the variable. If this is a variable 1, x2, then if I change 1 unit, that how much it will change in the decision, that will depend on the value of beta. So here, it's very important to understand that these coefficients tell us the importance of each feature or each attribute or each dependent variable. That's why this is the part of explainable AI or interpretable AI. So this is a just example. These coefficients can be presented in terms of the weights, right? In terms of the weights. And if you calculate, let's say, change or value of the T statics, the T beta G coefficient value, importance, will depend on the beta G value plus standard error due to the beta G. Okay. So here is the statics. So you know it, which feature is important in your data set and which feature is not important. That's why it's completely interpretable. The last one is a generalized adaptive models. These are the models which are extension of the simply regression models. In case of the regression model, we have the single Y, but generalized linear models, we have the multiple value of Y. Okay. So that's a general linear model where you have the multiple, instead of one dependent variable, we have the several dependent variables. Okay. Okay. So now there is another thing which is quite used commonly. These are more statistical generalized adaptive models. What is this? Because in the multiple linear regression or generalized linear models, we assume that relationship is linear, but in real life it doesn't happen. Sometimes so in generalized adaptive models, we apply the models in order to provide the maximum fitting. So this is, let's say, example. Here is a general model, linear regression. Here is the adaptive model. We have tried to fit it by some function. Okay. So let's say this is an example, spline curve fitting type of things, how you will fit your data. So instead of linear equation, it fits where? When you fit with some function. And for example, spline curve fitting. So now, what is the difference between multiple regression and this GA? Formula is same, except instead of beta 1 value, beta 1, beta 2, whatever the value we have, coefficients. Here a function is there. This is called function. And this function may be spline curve fitting, polynomial curve fitting, different type of curve fitting is there. Okay. And same way for the logistic regression, where it has the beta values, coefficients, it will have the function values. So functions, your coefficients are replaced by functions, which provide a fitting of the curve. So these models are more adaptive than the normal models.
But before,
okay, and these functions are called the link functions. Maybe Gaussian, binomial, Poisson. These are some example of curve fitting techniques. Anyway, today my major focus was on the model specific. There is a post hoc expressions where you have the apply any machine learning technique, whether ANN, random forest, blah blah blah, and then later on you can interpret it. These techniques are applied in your result actually later on to understand the result. Okay. So we have to understand one important part after this course of that how to evaluate this interpretability, because evaluation of model is most important thing in the machine learning techniques. So evaluating any model, we have the standard parameters like sensitivity, specificity, accuracy, AUROC, F1, kappa, many things. But not too many parameters are there for calculating the easiness, interpretable, explainable. So we need the same type of metrics to evaluate the explainability of a model. Actually, I will not cover today all these things because time is already. These are the some approaches. One is local. Local means individual instance predictions, because when we predict the individual instance and then we try to understand the meaning, then this is called local explanation. One is you take the whole data set, you predict it, and then you do the explanation. That is called global explanation. So I will not go into the detail. So again, we have to have the evaluation process, and that's all for today because time is already there. I have keep 10 minutes for the question answers. All right. So this is the just example if where we have applied the machine learning techniques in different biological problems, and these methods are heavily used by scientific community. All are freely available because this is an important part in particularly in Indian system. We spend a lot of time, lot of money on the commercial product, which is not required, which can be easily used by, can be solved by the open source software or public domain software. So I will advise you two things. Just learn how to use the public domain software as well as, if possible, contribute in the public domain software. That's all. Thank you very much.
Thank you, sir. Thank you.
Thank you so much,
Participants,
sir. Yeah. If there are any questions, really ask. We have around 5 minutes to take the questions.
Yeah, thank you very much, sir. Sir, I am having one question. Actually, I am working in the field of radiology. So, I am having some sort of the data from the X-ray as well as some CT scans. And then I just want to know that I am having a huge amount of data. Then I don't know that what kind of AI on ML I have to apply in my field. So, can you please help me?
Yeah, I will tell you, in case of image classification, best model is CNN, convolutional neural network. That is part of the deep learning basically. And they work best actually as far as I know. And most of the Python library, they support the CNN, like PyTorch, Keras, all right.
Okay, sir. Thank you very much, sir.
Sir, there is another question in the chat box. For deep neural networks, do we have standard number of layers? How will the model behave when we have fewer or excessive network layers? One of the question in the chat box.
Yeah, that's very important question. One of the problem we face from the deep neural network, because in deep neural network you have too many layers and too many hidden units. So how you will interpret? For that purpose, there is a post hoc explanations where they take it. There is a libraries like SAP library, SHAP, Lime library is there, which take the outcome and analyze it based on the input and output, and then they tell you what is the importance of that particular outcome. So there is a number of libraries are there. Unfortunately, I have not covered here today due to the time. In Python, there is a library like SAP, Lime, other libraries are there which can interpret it.
Okay, thank you so much. Due to a paucity of time, we will stop from here. Sir has really shared your valuable knowledge, and you have really enhanced our knowledge on learning. Thank you so much, sir, for giving your time.
Thank
We
you.
will definitely invite you for more lectures in the future.
Thank you.
So we will start the second session in a short while. I request the participants to stay online. Thank you so much.
सर एक बार भाई बोलो stop recording this.
Yeah.
You can play music now, okay?